Japan-Alaska Association's mission is to serve as an umbrella organization for Japan-Alaska organizations to promote friendship between our two nations and to create opportunities to share, preserve, and celebrate Japanese traditions with anyone interested in Japanese culture. We hope that you will choose to join our efforts to strengthen our community through personal and cultural connections. So what's a kotatsu? No, it's not a cat. Japanese of my grandmother's generation cooked meals, shared stories while eating mandarins, and created memories at the cooking hearth known as the irori. The kotatsu is a modern version of the irori, and now is found in most Japanese households in the form of a wooden table with a heat source. This piece of furniture is often the only source of heat and the central gathering place for Japanese families. These events will serve as an opportunity to create unity within the Japanese community in Anchorage and beyond.
Good afternoon, everybody. As a continuation from our first series a month ago, we're honored to have Dr. Akasof with us today. And just like what we did before, really an opportunity to get to know our guest and to have him introduce himself to us, and we're all very eager to learn more about you. So, Dr. Akasof, thank you for joining us.
I'm very honored to be here.
And maybe let's just start a little bit about what brought you to Alaska and when did you arrive?
Yes, maybe first of all, I was born in the very countryside, in a highland, a very small town, and my very early recollection, one of them is that my mother used to sing a particular song she liked so much, and in that song, the title is something like The Wanderer's Song, and the very beginning of the song was, I wonder if I should go ahead in Siberia or I should go back under the aurora. And so that word aurora stuck in my mind. I'm sure I asked my mother what it meant, because she really didn't know, didn't see the aurora. But that particular song, if perhaps you know Kitahara Hakushu, very famous poet, and Nakayama Shinpei, he was a songwriter, very famous. And this was apparently in the theater that Matsui Sumako, that she was one of the greatest actresses in Japan in those days. For some reason, my mother liked that song, and so almost like a lullaby, I stuck in my mind. So that's the first time I heard the word, the aurora. Of course, those days no one talk about the aurora. Then, of course, my younger days, we had a war, and then after the war, I wanted to be a meteorologist, weather forecaster. So I went to university in Sendai called Tohoku University, and there was a department of geophysics that teaches weather forecasting and many other geophysical things like volcano, earthquake, many other things. And I was very much interested in mountain climbing those days. And Of course, in Tohoku University, mountain climbing meant skiing.
Mm-hmm.
And that's very expensive things. You have to buy ski boots. And so I was looking for a job to get some money. And there was an announcement looking for some help for what they call magnetic observatory. The Earth is a magnet, and they're changing all the time. So they're recording magnetic changes all the time. And the observatory was in the cave, very dark cave. The only things I could see the spot of light from the instrument. And my job is to change recording paper every day. That's one of the jobs. And I saw this spot moving, sometimes very slowly, sometimes violently, sometimes oscillatory changes. So I asked the manager of the observatory, what's causing those changes? I had no idea. So he said, must be the aurora in Siberia or Alaska. That's far away distance. So that's the second time I heard the word aurora. That time suddenly my memory came back.
From your childhood?
Yeah, right.
Mm-hmm.
And actually my memory was so secure, but it so happened that my mother's death, after 1 year we had a family gathering. My uncle and aunt told me, do you know that your mother had a favorite song? So I said, and so I wasn't sure. So they, all sing together. And so they sang. That is exactly their song. So my memory was right. And when I heard the second time the aurora, I thought it's very interesting. Then manager told me that why the aurora causes those changes. That time wasn't known. So I thought, rather than far away in Japan to try to understand, rather why don't you just go under the aurora in Alaska? So that I thought. That's the second time. Then I became a graduate student, and I attended one of the meetings. And I asked, somehow, I don't remember exactly, I asked a question to the presenter. And then he said, do you know a paper by Professor Chapman? So I never heard of anything. Then you are not qualified to ask that question. He was angry. So I went back to school, the library. I found the paper by Professor Chapman. But it was so difficult to understand. I think even now it's a difficult paper. So I decided to study the aurora. The only way I can study the aurora, I thought I had to understand Professor Chapman's paper. So I wondered for a while and then decided to write to him. I saw so many questions. Then I learned that he was a professor at Oxford, very, very top guy in geophysics. And I never thought that he could respond to me. Just a youngster asking world authority. And so I decided not to write to him. Then I had to I had to go to the South Pacific and this and that. Then I found he visited University of Alaska, the Geophysical Institute, every year. Okay, then I could write to him in Alaska. So I wrote to him. I never expected any response. Then, surprisingly, about 2 weeks later or something, I received a letter from him. And it simply says that he cannot answer all the questions I sent. So why don't you come under me and study, come to Alaska, study with me. So, of course, poor student, I didn't have any money. Then, a few days later, I received money as a check for the airplane. So,
to meet him in Fairbanks.
Yes. So I had no choice. So I told my mother I'm going to Alaska. She said, "Oh, wasn't that an enemy country just 10 years ago?" So, yeah, but it's okay. The world authority asked me to come, so I have no choice. So that's the way I came. I arrived. I think it was a propeller plane, refueled in somewhere in Aleutian. It was before the jet plane age. And it was. I arrived in Fairbanks December 13th, 1958. I remember this very well because 2 weeks later there was a siren in the morning, woke me up, and I asked my friends, what's the siren, what's it for? And he said, Alaska has become the state. So it was, when I arrived, Alaska was still not the state. Yeah.
When you arrived in the month of December, were you shocked with the weather of Fairbanks then?
No, I wasn't. The place I was born in the Highland, and we had a fairly cold temperature, of course, only about -10. So and also my days during the war were not used to gloves. Think of soldiers in Manchuria and all that, and we couldn't use the socks, so just a Japanese sandal, the geta, and the barefoot. And we were so bad students those days. Sometimes a teacher got mad at us and asked us to run with the snow-covered ground while barefoot. So we're used to.
Yeah, no,
so
definitely.
But that particular day it was cold. I don't remember. But cold temperature wasn't any problem for me. I didn't worry about when I came because just about months before I was in South Pacific, hot, 30 or 40 degrees to minus 30 degree 40. So 6-degree temperature difference, but I was not concerned. I don't remember that. I was
now, 1958, when you arrive, was that pretty much the beginning of your long, distinguished career at UAF and in Alaska? Did you go back to Japan and spend more time, or did you stay in Fairbanks permanently?
I stayed. Of course, those days, you could not go back. My visa, I could not go back for 2 years anyway, and I didn't have money to go back anyway. So I stayed, and so that wasn't any problem.
Now, it's you've had many years in Alaska, and particularly in Fairbanks at UAF, and we've all had the pleasure of learning just a little bit about that. But are there any particular accomplishments that stand out to you that maybe you feel most proud of?
My professor Chapman, he retired just before I went to Alaska. Somehow he decided to come to Alaska. I think he was interested in the aurora. So I started work with him right away, and he was really became my mentor. Really, without him, I wouldn't be anything here.
Mm-hmm.
So he was my mentor, and he and I worked very, very hard, and helped me in many ways. And so the first thing I had to do, one of the first things I had to do was in the past, before I went to Alaska, the aurora was studied in many places independently. There is no way to observe the aurora all over the world together. And of course, aurora covers dark side of a polar region. So you need, now it's very simple. You look down by satellite, you can see the whole polar region. Those days, there were no way. So Professor Chapman and his colleagues established many camera stations, about 50 camera stations, all in the northern hemisphere. So some in Siberia, some in Canada, Norway. And they agreed to take a picture every minute, regardless of weather, on the dark night. So all the films came to the Geophysical Institute. So I had an opportunity for the first time. The scientists, aurora scientists, could look at the aurora, Alaska, Siberia, Canada, or any polar region, all together at the same time. So I worked on it, and then finally I found out what's going on. And of course, no one has done this before, so very difficult to convince the people of what's going on. So it took the first satellite went up, took a picture from above every minute, was 1982. So I published my paper in 1964, so it took many years that my work was confirmed. Fortunately, people start to recognize my work. And one of the most, I think, I don't know exactly what it was, but anyway, there's a citation index that people use. I was chosen one of the 1,000 most cited scientists in the whole science field. I was really surprised myself. So lots of people are interested in my work. Of course, I'm sure there's opposition too, but nevertheless, people took my work. Technically, that's called aurora substorm.
Thinking, Dr. Akasof, with thinking more about the work that you've done, especially when you started getting notarized, maybe 6-7 years after you arrived to Fairbanks. Can you talk to us a little bit about how the geophysical department or the Aurora research at UAF maybe continued to grow? Were you able to get new funding? Were you able to get more attention for your department, to have more researchers come in about your topic because of the work that you had done? How did it continue to grow over the years?
Okay, it was beginning of a space age. So without satellites, you cannot really learn about the aurora. Aurora is a gigantic electrical discharge. And so there must be a generator in the sky and so on and so forth. That without satellite, we could not study the aurora well. Only from the ground you cannot do that. So I was very fortunate that my study began with satellite age, space age, and so I don't think I had any problem getting research grant from NASA or National Science Foundation. No trouble. I can tell you, in fact, one story that just before the satellite age, we had to use aircraft to study the aurora, observe the aurora. So I went to NASA. I need a 4-engine jet plane. I mean, if you go there now, they think I'm crazy. But those days, go ahead, use one. So I had a 4-engine jet plane, and for several months at least. And I flew many hours, maybe almost 300 hours, flying all over the polar region. And that could be done because of the space age just began. And also Air Force, those days they're very much interested in the aurora. And so they gave me a 4-engine jet plane, specially designed for that. So it's still one of the big topics in geophysics. There's, I think at the present time, 7 satellites up try to find out the cause of the aurora. So fortunately, in my research, I had no problem getting any support.
Well, speaking of the space age and the technology at the time, Dr. Akasofu, if you could imagine perhaps that you were born a generation before that you were actually born, what do you think the research would have been like then to study the aurora? What were the people before you, and perhaps Dr. Chapman, what were their limitations? What were their techniques compared to what you were able to do that?
I would say even my days, 1960s, 70s, my early days, the study, I would call it the Aurora Stone Age. It's now so much more advanced, 1990s to present. So what I did was a sort of a Stone Age, just using a camera on the ground. Now you can take a picture quite easily from a satellite. A big difference. So
you've seen it change a lot over the years.
Yes, but still, so many things we don't understand, and for longevity, maybe because of that, I could still study, and I'm still writing papers and arguing with my friends.
Continuing on with thinking about your career, but also maybe combining that about where you're from in Japan. Can you talk to us a little bit about how being Japanese has perhaps benefited you, or maybe been difficult for you at times, living in the United States, trying to do your research, trying to get published, and of course arguing, for the research that you do. Could you talk to us a little bit about how culturally you've had either challenges or benefits perhaps of being Japanese?
Let's see. As far as the aurora is concerned, there's no problem. I try to help them. I went there many times, lectures, and they listen to me, of course, and so on and so forth. But the more I decided to help Japanese scientists to study the Arctic. And so I started work on this soon after I became the director of the Geophysical Institute. It was 1986. And so I tried to bring as many Japanese scientists to Alaska. And that's one of the reasons I established International Arctic Research Center that many Japanese scientists can visit. But for most Japanese people, Arctic is somewhere, their concern of the Arctic is less than, I tell them, backside of the moon. They don't much, they're not particularly interested in the Arctic, although their weather, for example, very much influenced by Arctic weather. A very cold winter, of course, as Arctic air goes down to Japan. So long as Japan is in the northern hemisphere, they should be very much concerned about. Unfortunately, they're still, they think the Arctic is somewhere even backside of the moon. So I'm working as hard as I can, and only recently they decided to build the icebreaker, so it's a good sign. And also, I have an advantage compared with Japanese scientists. If a Japanese scientist wants to do, you have to go to department head, and then president of university, then from Ministry of Education, Science, and then many levels of civil servant, bureaucracy, and then whoever to the minister. I have no problem because I don't have to get any permission from anyone. If I want to see Minister of Science and Technology, I just go there. I will see.
You have permission to go straight to the top.
Right. So actually, I help them to get their research fund twice. And I'm trying to tell them now them to have their National Institute of Arctic Research. So I'm still working on that. And so then they will have a stable funding and can work with us more closely.
You know, you mentioned the International Arctic Research Center. You mentioned icebreakers a little bit earlier.
Yeah.
Can you talk to us a little bit about what are some of your hopes for perhaps Japanese Americans, frankly, the world? What would you like to see more of? What would you like to see progress, whether it's for the university or would you like to see more Japanese researchers continue to come to Alaska or elsewhere? What are some of your hopes and goals?
So I thought that University of Alaska can be a real Arctic university. So if I could do something so that scientists all over the world can come together, study Arctic, that would be great. There are many universities which are specialized in Arctic research, but just one, like University of Washington in Seattle, they are very expert. They are part of Arctic Ocean, but know nothing about the rest of the other aspects of the Arctic. But the University of Alaska has many institutes, fishery, biology, and many other things. So it's good that if we could establish an international Arctic research center, the University of Alaska can become really the Arctic university. So that was my main goal. I started to work on it. I thought we needed Japanese funding, so I went to a ministry of education in Japan, and one bureaucrat said, "You should come to me after you get the Nobel Prize."
Then we can help you.
So I said, unfortunately, geophysics, in Nobel Prize, geophysics is not a category. And then he said, get Al Gore's letter. And so, okay, fine, I'll get it. And, took about 4 years to get to him. And he really wrote a 2-page letter saying that we're going to work together. And so Al Gore's letter went to embassy to foreign ministry right away, and the top level I mean, later from Arcoa go all the way to the top. So in 1 week, the Japanese government replied that let's establish Arctic Research Center together.
Wow.
Yeah.
And there it began.
It took 4 or 5 years.
Mm-hmm.
Yes.
And that was the first year of the International Arctic Research Center officially. Was that 1998?
98 or 99.
Okay.
Yeah.
Mm-hmm.
Yes. So that's the reason that I hope that the University of Alaska will be truly Arctic University. Practically all the aspects of Arctic will be studied together.
Even today, Dr. Akasof, do there continue to be quite a lot of Japanese researchers that come to Fairbanks that study at UAF or for the center?
Not only Japanese. I was surprised when I established International Arctic Research Center. Largest number of scientists were from Russia.
Oh, okay.
Yes. But they come and go all the time.
Mm-hmm.
So we work practically every country in the Arctic and
Mm-hmm.
others together. So, from Korea to China. So Japanese is not the exception.
Okay, it's just one of many.
Yeah.
Are there any particular countries that you are seeing more of than before, that perhaps the Chinese or elsewhere that you feel like are beginning to show more and more interest in the Arctic?
I think, as I told you, both China and Korea seems to be more interested in the Arctic for various reasons. But Japan, hopefully, finally, they are waking up. It took many years.
Well, we know that you've spent a good majority of your career at UAF and in Fairbanks in particular. Could you talk to us a little bit about what the community of Fairbanks is like and what the Japanese community in Fairbanks is like, as far as where do they often tend to come from? And
as far as I know, there are many, the Toyota, Nissan, all this, but I don't think anybody stays there from Japan. So I think most of the people are university related. But nevertheless, once or twice we have a gathering, summertime, all the Japanese related people come together. And I see so many young people. Not necessarily related to the university.
Mm-hmm.
There may be gold mines there.
Mm-hmm.
So there are some people from gold mine. For some reason, I see so many young people. Yeah. So we meet only once perhaps, maybe twice, except some special event.
Mm-hmm.
Sometimes some performer comes and so on.
Mm-hmm.
Other than that, so they're small, but there's a very nice community.
Good. You mentioned earlier that you continue to research even today.
Mm-hmm.
Can you talk to us a little bit about what are some of the topics or some of the things that you're paying attention to and that you would still like to try to accomplish?
Thank you for asking me that question. When I established the International Arctic Research Center, that was supposed to study global warming. And that was not my specialty, but I thought because I was director, so I should do something. So I started to work on it. And my finding is that global warming, they talk about these days in press and everybody's not accurate. In fact, when I said, because I said that, some of the Anchorage newspaper said Akasof is the Alaskan most famous skeptics of global warming. The reason I say is that this is a field called climatology. And climatology is a field you study the past climate change and learn about it, and then using that knowledge you are supposed to infer or predict future climate change. I'm sure you know the organization called ICPP, Intergovernmental Panel for Climate Change. It's a big world organization. They are interested in only computer simulation of future temperature change. They don't really study the past climate change. And that's completely wrong to me. In fact, the present warming began 1800. All the world glaciers, including Alaska glaciers, start to recede around between 1800 and 1850. The carbon dioxide began to increase after 1946, the end of the war, last war. So before that, carbon dioxide is not very much of anything. But glaciers start to recede well 100 years before. So warming began around 1800, almost straight line increase.
What's it been like to, in your field in particular, and maybe even in the press outside of Alaska, as you've stated your findings and your research on this topic that is very interesting to many people, have you felt like people in your industry and in your field have been supportive of you, or have they been quite kind of surprised or
Yeah, so we are few skeptics or deniers. So, I tell them that science, the essence of science is a debate. Tell opponents, skeptics or denier is not quite right. And so we are few, but the reason we have warming is mostly, I think, due to what we call little ice age. It began, very interesting that around the year 1000, the earth was warmer than now, perhaps some people say. Lots of people immigrated to Greenland. Then 1200, what we call little ice age began. So all the immigrated people died out. Very interesting histories why Greenland community collapsed. Only people survived, the native people. Then this cold spell continued till about 1800. Actually, River Thames in London frozen in the winter time, and Hudson River frozen also. So Washington had a hard time to cross that famous picture. So it was cold, and then we began to recover from little ice age. Recovering from a cold period is warming. So most ICPP misunderstand this warming with the CO2 because they don't study the past change. So that's my feeling.
Well, we could easily continue to pick your brain on this topic, but as we maybe wrap up the questions for today, could you, thinking about your long, distinguished career and everything you've been able to do, do you vision yourself ever fully retiring? Are there places you want to go? Are there anything that you want to see anytime soon that you haven't been to yet? Can you just talk to us a little bit about how you might want to spend some of your free time, if you have any?
Yeah, maybe I would say that I ask my wife. We said we have fortunately meeting every few years meeting in Hawaii, but she doesn't think that's a place to stay. So, but the kids and the grandkids in this country, so I'm sure she will stay.
Yeah.
Yeah.
And you continue to plan to call Fairbanks home. Your daughter lives there. You have grandkids there.
Yeah.
Fairbanks is going to be home.
Yes, I think to me, 30 below zero doesn't mean much.
Yeah, no big deal. Like you said.
This year, I used the graph only once. I hate the graph because I lose it.
Wow.
So my wife complained about it. She buy me a new one. Almost a few days later, I lose.
So just don't wear them.
I'm afraid of losing. So even 30 below zero, I don't use the graph.
That's cold. That's cold. But yes, strong fingers. Maybe last but not least, I know others here would probably be interested in this, as am I. Do you have any aurora viewing tips for us? For us, that we look at the forecast in the paper, we see it a little bit in the news. For us, people that aren't in the field of science, where are some of the best places to go, and what should we be looking for in weather patterns to determine if it's a good night to see the aurora?
Okay, because the Japanese tourists go to Yellowknife, so Norway, Northeast. So, when they ask me to come to Alaska in the spring, because in the Norway area, the weather is not very good in winter time. The Alaska, fortunately, have a very nice springtime. It's very cold, but clear weather. So that's one thing. But the prediction is the aurora activity. You have to learn about the sun. Actually, what we are doing, in some way, we are studying the sun through the aurora. Sun, so many things we really don't understand. Very strange stuff. So we are trying to understand the aurora is just a part of what they produce. And so we have many prediction schemes. When the sun explodes from time to time produce a big gas come out from the sun. So now we have a good computer program how it propagates from the sun to the earth, if we hit the earth or not, so on. But forecasting the solar eruption, we call solar flares, solar physics hasn't succeeded yet. We are actually helping them. It takes about 2 days for the solar gas to reach the Earth. So even if you learn that there was an eruption on the sun, and so make a reservation, fly to Alaska, may not be in time.
Yeah.
So, but there is one thing that Aurora has. It's repeat activity every 27 days. That's because the sun rotates like the Earth every 27 days. There is one active region, so it's come around every 27 days. So when we see good aurora January 1st, within accuracy of a day or two, we can predict good aurora January 27th.
Oh, okay.
So we can use that. So we are using all kinds of knowledge like this to come out as a aurora forecast.
I see.
Yeah. But Anchorage, unfortunately, a little, and when solar activity is low, we can't see much in Fairbanks. It's north of that.
Yeah.
Actually, when you look down the Earth from above by satellite, aurora appears about 360 days. It's always there.
Oh.
The only thing is that as it appears a ring, the solar activity is low, it shrinks. And so small ring is located at about Alaskan Arctic coastline. So from our observatory on the top of the hill, Boca Flat rocket range, we can see it. But for downtown Fairbanks, you cannot. So in Fairbanks, people say there was aurora today. So it's always there, but the ring has to expand. And when the big solar activity comes, the ring expands way south of even Anchorage. So Anchorage people even miss that.
Wow.
Yeah. So it's changing all the time. So it's not easy to.
It's not easy to predict and see all the time. For our members and visitors, are there any particular questions?
I understand other planets also have aurora, the planets with the magnetic poles.
Yes.
Can you talk about this, please?
The aurora, as maybe I didn't tell you, it's a gigantic electrical discharge, or better way, maybe neon sign. The basic principle is a neon sign. When you make neon sign, you have a glass tube, vacuum it, and put a little neon gas in, and then connect to a high voltage. Then you see neon sign. So actually what's happened is that in the upper atmosphere we have a big electrical discharge. So that you need electricity. To have electricity, you need a generator. Generators produce electricity. And power plants is nothing but a generator. Okay, so our job in early days, space age, was what is the power of the generator, and what is it? Where is it in the sky? That was what we had to work. using satellite. And the power is very huge. If we could use aurora electricity, you don't need any generator on the Earth. So it's a huge generator. The question is, where is it?
Mm-hmm.
It's up in the sky. We found out where it is. And to have a generator, you need a magnet. You know, the generator is the simplest machine in physics. All you need is a magnet and a coil. And the Earth itself is the magnet. So we expected that Jupiter, Saturn, we knew it has a magnetic field.
Jupiter and Saturn. Jupiter and Saturn. Okay.
We expected the aurora there. Mm-hmm. And then they found out there's aurora. On the other hand, Venus, Mars, for some reason, it doesn't have a magnetic field. So we did not expect the aurora. And many satellites went there and couldn't find anything. So that's confirmed sort of, our understanding of the aurora need a generator. To have a generator, planet has to have a magnetic field. And both Jupiter and Saturn has it.
Jupiter and Saturn. Okay.
Yeah.
Yeah, very interesting.
That's okay.
Questions?
Mine is a very basic question, but during your 60 years of extensive research of aurora, I think that I think you observed countless aurora, but none of them identical, or sometimes it's identical. There's no same aurora.
That's true. Basically, aurora is a curtain of light. Basic form is the same. But it's, become draperies and all kinds. Aurora is so big compared with us. It looks quite different. But it's how it's moved around, all that. Looks every day aurora looks different, but there is a pretty systematic change, and that's what I actually came out. The aurora subsong, aurora has a very special pattern of development, and it usually big activity lasts only about 2 hours or so. Over one night, that may occur once, maybe occur twice, or depending on the sun. If the sun is active, you may be able to see 3 times the aurora activity. The basic pattern is the same, but the individual display, depending on so many things, looks quite different.
I'm glad to see you today.
She's very honored.
I've known you, Dr. Akasof, about 30 years ago on the Geophysical Institute. I've read it. So before I was born, my daughter, Erica, we have a very excellent authority about aurora. I didn't know about aurora at that time. I was in Japan. And so we have Dr. Akasof very working hard aurora. And one person in the world. So I was instantly I respect you. Wow, what a great person. So working in Fairbanks.
Yeah, I think we all feel very honored and just fortunate that we can have you here with us in Alaska. You know, we are a big state geographically, but population we're very small, and to have someone like yourself with the kind of history you have just makes us all very proud of you and of the state, and particularly Fairbanks. Thank you.
Yeah, of course, you know, I think the whole world, there may be, I don't think more than 1,000, let me say 5,000 people studying the aurora. There are all kinds of things we have to study. Like some people studying effects of the aurora. Sometimes it causes blackout, and it causes trouble in Trans-Alaska oil pipeline. So there's so many things, and also damaged satellites. So we have to predict the occurrence of the aurora. So there are so many people work on the aurora. Some people are interested in what's caused the aurora to be. So I would say there are about 500 people, and one of the big topics is actually what causes auroral activity. I'm actually minority, but I think I'm winning. It's a big scientific field. We have a big debates.
Mm-hmm.
So for some people, they don't think I'm an authority. Anything, yeah, that's fine.
May I have one more question?
Oh, of course.
Global warming change is cycle of system, Earth system, or universe system. So that's why getting warmer.
Yeah, I
Earth's
think.
temperature. And
Yeah, what I can say is that without human being on Earth, the climate changing all the time. We had the big ice ages, at least as far as I can go back, there are 10 times big ice ages. Temperature went down to minus, let's see, centigrade minus 10. So up and down. And also many small changes all the time. So those are natural changes. And so to distinguish between natural changes and man-made changes is very difficult. You can compute, it's very simple. Carbon dioxide can do something, so if you put in the air, it will happen. It's not that simple. Much of the carbon dioxide go into the ocean, and air, which height it can contribute to warming, the big difference of opinion. So it's not as very simple. So I think it should be this global warming or what. Should be academic subjects. I don't know why they brought up to public. It should not. Still answers so much uncertainties. Scientists only should discuss that. It's not a public thing yet, until it's very sure that. But some people try to, so anxious, try to put it on public. That causes a problem. So it has become a political problem. And so like President Trump, he doesn't, for some reason, he doesn't believe, so he wants to take out all the climate change research. So rather, so long as it's academic matter, that wouldn't be influenced by politics. But put it in politics and we'll have a problem. He wants to eliminate much of climate research.
Yeah, he eliminates 35% EPA budget.
Yeah.
So Dr. Akasof, no objection, Mr. Trump.
Yes, to rephrase your
Oh, sure. So basically, I think she's saying President Trump has proposed to cut back the budget for climate research and those related things. What are your personal and professional feelings about that? Will that be detrimental to us? Do you support that, or in between, or?
Okay, so mistake was made at the early beginning of climate research. It began about 1990. People put it into a public domain and into politics. That's the reason that it's up to politicians now to decide. And so mistake was made that time. So long as it remains academic matter, no politician knows anything about it, they don't touch. But they put it in public politics, so we suffer from politics. Mm-hmm. And that's too bad. And it's a very important study. We have to understand the future climate change. But because it's in politics, they suffer. And I would just say too bad. And we should have, as a scientific study, we should get support, from the president, which is future of the earth. So it's important. Mm-hmm. But it became so politics, too much politics, and that's why I feel the suffering.
I would imagine that it's the economics behind it that just create and just add to the politics as well, and then it becomes a dollars and cents argument too.
President Trump wants to enhance the coal burning. Mm-hmm. That's why he doesn't like the CO2 issue. So this is academic matter. Still should not become political matter. That's the trouble. And then you see, they say the advanced countries are putting CO2. Small countries in South Pacific, they suffer. They think the water level will go up. If so, advanced countries should pay for them. And so Japan, very political good students, so they pay. But this way, this kind of payment, you cannot control. Japan gave Indonesia big money for stop CO2. But they use the money in entirely different way. In fact, increasing CO2. So instead, if Japan has to pay to developing countries, it should be aid to their economics. That's so much better. Now, CO2 money is a penalty. So whole thing that's a political issue. That is a problem.
And I can imagine, Dr. Akasof, my guess is perhaps when it is time when Japan may need something, perhaps in the United Nations, the developing countries could very much perhaps be a friend of Japan, and the politics is intertwined in that way too, right? And the same goes for us too.
We have a meeting next January, a big meeting in Japan. So we are going to discuss that. So Japanese government might understand a little better what's going on.
Yeah.
Back to Aurora. So when I go to taking a tourist, and I'm going to Fairbanks a lot. So when my research is going to the Geophysical Institute, the Aurora focus, the number 0 to 9, and usually we see number 2 or 3, which is pretty good. And last couple of years we have a 4 and 5, which was kind of high to me for so many years. I'm doing tour guide. Every 11 years, the Aurora had peak, and the peak was I think 2 years or 3 years ago. I think.
Okay.
I thought it's a downtime, but I see the number is high. Also, why National Geographic Institute put the 0 to 9? Why the 5 is pretty active? It says it's kind of affect for the electrical thing. So why 0 to 5? Oh, then number 2 is pretty high.
Okay.
Could be a 9 one day.
The sun, we don't know yet. We don't know about sun, but sun has an 11-year cycle. So if you watch a sunspot increases, takes about 4 years, and then it reaches a peak number, and then goes down. The big eruption tend to occur near the peak where there's lots of sunspot. And also sun has a very strange place. It all depends on the gas from the sun. It's related to sunspot. And so because over 11-year cycle, first of all you have some years where you see lots of aurora, some years don't. If there is no sunspot, you may not see any aurora. And we put 1 to 9. We can guess reasonably well by watching the sun what kind of gas from the sun is coming. So we try to, as much as possible, the speed, solar wind, we call solar wind, the strength of solar wind, just like a weather. And sometimes we expect when there's a big eruption, then we put a 9. When there's no sunspot, put 1. Yes. And then it changes every day. So we try our best, but it's not easy.
Also, have a pattern when we see in the northern light. Well, during the night, it has in the beginning it's just a line and getting sometimes going towards to sky, but horizontal. Then coming up, northern lights.
Yes.
Is that the pattern of your talking about ray? You said many different aurora during the night, but some pattern to break up, which when you see the northern lights goes kind of vertical, horizontal, then will be that's the night of one day you can wait.
Yeah. Yes. This ring. First of all, we have to guess where it's going to be. north of Fairbanks or south of over Fairbanks or south. That's the first thing we have to check. That depends on the gas from the sun. So we have the satellite watching the gas from the sun every second, accuracy what's coming. So from that, putting other things and try to infer where the size of the ring. And then if this particular activity I told you about, auroral substorm, might occur once a night, even if ring is big over Fairbanks, it might have just once or twice or sometimes 3 times. That's a very too difficult at the present time. We know there's one thing that in solar wind we cannot forecast, and there are many parameters in the solar wind which affects the weather. But the one crucial parameter we cannot predict. So we can tell you what times the aurora starts active. We can do this only 40 minutes before, because there's one satellite located between sun and the earth. And from that, solar wind takes about 40 minutes to reach the earth. So 40 minutes before we can tell you. That's too short for the Japanese people too.
Yeah, for the tourists. Or they call you at the hotel, and then you have to get in the express van.
Wait in the don't have to be outside.
in the room, right?
Yes,
And
yeah.
also, you said there was a device to see aurora at the same time in the Arctic region.
Yeah, the satellite.
Satellite
Yes.
at the same time.
Yeah, we
I
can.
mean, I'm talking about like the aurora that you see from Norway, and then aurora that you see from Fairbanks.
Yeah.
Are they the same or different?
Okay,
they look different.
About the same, but basically it's a cardinal light. That's the same. But the difference is in activity, how it's move around, curl around, all that. Depending on the time of the night, it tends to be much more active in the midnight, and the evening is usually quiet, and midnight is very active. So if you want to compare the aurora in Norway and Alaska, it's the difference is the time difference. Aurora in the midnight Fairbanks are perhaps very active, still curtain-like form, but in the morning curtain breaks up into pieces. So in Norway, at the same time, you see quite different pattern. Yeah.
Can you speak about the mirror effect of Australia Borealis and Aurora Borealis, the North and South Pole? Can you talk about that discovery and that phenomenon?
That's the difference.
The mirror, I understand it's
Yeah,
a mirror
yeah. I've
reflection.
only heard a little bit about it, but what they see in Australia and New Zealand and very south compared to us.
The aurora, it's the same ring.
Yes.
The Arctic, Antarctic, and of course now you can see by satellite, but we use special 2 planes flying north and south, and exactly the same location as magnetic field lines, the foot, and almost the same.
Yes.
There's a little difference, but basically, when the aurora is quiet, it's quiet,
Yes.
both, and active, both active, and the way it becomes active is about the same.
Yes.
So it's equator is making all the changes,
Yes.
and can affects the aurora north and south.
Indeed.
Yeah.
I find it fascinating, and in our lifetime we've learned that the geomagnetic shift happens in a certain period of years. So I've always wondered, what happens to the aurora when the north and south poles shift? Is there any scientific idea?
Happens. The Earth is a magnet, as I told you, but at the present time, the magnetic pole in the Arctic is the south pole, the magnet, and sometimes apparently it flips, but that's about a couple of million years, so we don't have to worry about it. But the sun changes this every 11 years. Yeah.
Oh,
So do you have communication, south and north scientists?
So
Do you have any communication all the time from Fairbanks to the South Pole scientists?
Oh,
Yeah.
yeah. I mean, are you doing a lot of work, or does your research center do a lot of work with perhaps the universities and the institutes in that part of the world?
oh yeah, of course. Yeah.
Mhm.
When you're early time without the satellite, did you wake up all night to watch Northern Light to study?
Okay.
And then working on the daytime too?
Basically, you can't sleep.
I can tell you one story that
He never had frostbite.
I had
Yeah.
I had a dormitory. I stayed in dormitory with my friend from India. So he smokes all the time, but I never use the tray. Just every year he drops.
Oh.
And one day there was an inspection, and we were thrown out from dormitory. So I had to find some place, and there was, I don't know if all the people, there was an army Quonset, and not heated even. And so there's no money to find apartment in the downtown, so I stay there. Very cold, everything is frozen, and I had the sleeping bag, 2 bags, and so from time to time I had to wake up, peeing. So I had the
Middle of
time
night.
to watch the aurora quite often. that was a quite a good experience. I mean, most of the people sleeping, I could
So-
watch the aurora.
When you arrived in Anchor, Alaska, that was December 13th, 1958,
Yes,
right?
yes.
Yeah. So when was the first aurora that you
Mm.
saw right after that?
That's one thing I don't remember.
Oh.
Very strange. I was interested in
Mhm.
other things. I was interested in mountain climbing and all that. So,
You can't.
so
Yeah.
I really don't remember.
Is there any-
I remember my wife's. She couldn't stand, so there was a big display, and she was really not impressed. I mean, she had to almost kneel down. She said she was so afraid.
Oh, kind of surprised
Yeah,
by
surprised, yeah.
all of it. Yep.
Yeah.
Do you have
I don't.
any-
Unfortunately, I can tell you if I.
You've seen many auroras.
Somehow I don't remember anything. First time.
One more question,
Oh.
stupid question. Have you had a dream you want to become an astronaut?
An astronaut. Have you ever dreamt or ever wanted to be an astronaut and go to outer space?
I'm not a good car driver, so
So no. Yeah. But,
You don't drive?
yeah, I drive. I had an accident twice, so
Well, thank you so very much. This is very my honor and my pleasure This is Rose. Thank you so very much. My son's also, his major is geophysics, and he always talking about magnetic electronic power or some data, and he tried to explain to me, but I didn't get it. But today it's very, very understandable, very more detailed. And I want to ask you about why the Japanese. You say IARC. They have a lot of students came from all over the world, like Korea, China. But you say the Japanese, they're still thinking Arctic sector, like the moon or some part of
Far away.
Far away.
Yeah.
So why is the reason they don't think like a more global, like especially global warming issue?
Yeah. Your question is why is Japanese so much interested in the aurora?
No.
Well, why aren't they more interested in Arctic research and how they might maybe contribute to that? I mean, is it just more of is it cultural? Have there not been a lot of researchers from Japan? Or
enough information?
Yeah.
Actually, Japanese Arctic research are not very large group, but they are, for some reason, Japanese people, including the emperor, are very much interested in the aurora. But I find that these days there are many Taiwan people come, Taiwan, Korea, Chinese people come to see the aurora. So, of course, American people are very much interested. Only difference between Oriental people and American people is that people come from the Orient know that it's only winter time you can see the aurora. American tourists in June they can ask me, "Can we see the aurora tonight?" Look at the sky. So
Good luck.
This is very simple.
Yep.
The Iowa, for example, the midsummer is still dark, and sometimes you see the aurora. So they think Fairbanks summertime you could see the aurora. So they don't. Their first experience of Arctic night, midnight. Yeah, they come quite often. I'm very much interested in the aurora. Can you predict the aurora tonight? So, look at the sky.
If I may ask one more question. I understand in the last 100 years they've had an extreme aurora, like the Carrington effect, and that even down in the lower 48 they could see a red aurora. Can you talk about that, predicting it, or concerned about that?
Once in 100 or 200 years, the sun apparently had a big explosion. And in that case, all over this ring went way down. And so people we have a record, people in Hawaii, India, Mexico, fortunately they left some of their sketch, so we collected them. So that could happen. Perhaps once in 100 years, like. Of course, if that happened today, there will be a major problem. All the satellite malfunction, and maybe outage too. So people, one of the things they have a study called the space weather. They are trying to really forecast that big explosion. That would be major trouble because all the communication satellite, everything broke down. In fact, Defense Department, I was asked, good old days, you can communicate U.S. and Africa, just one simple radio.
Mm-hmm. Mm-hmm.
That will not be affected by technology stuff. So they should still keep shortwave radio, making sure that anything like that happens. Well, like a tsunami, that tsunami is every 1,000 years.
Yeah.
We don't know. That definitely something very intense things happened for sure. But since then, that was the 1846 or something like that. Maybe little less, few times. But the last biggest one was 1958, February. But wasn't no comparison to what's happened in 1850.
Isn't the aurora, the nighttime activity in the sky, is not harmful for human beings, right?
Harmful.
Harmful.
Is it dangerous, or could it affect us in any way as humans or even animals?
In the Russian publications, there are many articles which say that admittance to mental hospital increases when aurora.
like a full moon.
But the aurora produces X-ray too, but it stopped around 300, about 3 times as high as jet aircraft altitude. So even jet craft will not be affected by X-rays. So aurora does not affect health, maybe mental health.
I have a silly question. Do you know about the story Americans are believing why Japanese coming to Alaska to see Northern Lights? That story, do you know about it?
So just I think what's happened is that some 100 years ago, Japan opened up the whole world. There are many things that never happened in Japan, like a desert, aurora, glaciers. So they are fascinated by those that they could not see in Japan. So I think aurora is one of those. The only thing that Seattle television station made up a story that if you conceive baby under the aurora, the baby will be very intelligent.
But no truth to that?
There is no.
Okay, I confirm.
From the source.
I wanted to know.
Yeah,
We didn't know. I didn't know. And I heard from other American tourists asking me.
Yeah.
So I always telling Americans, look at my clients. They are 60s and 70s.
Yes.
So that's a commercial, a TV made up.
Yeah.
Okay.
Yeah, so Seattle's television.
Okay.
Fake news.
Yeah. Well, I think a fantastic way to end, and thank you very much.